Here's what a typical doctor's dictation might look like. So it has, as you can see, it has all kinds of information, a lot of detail hidden into it. But many times for a research project, we are only after a small piece of this information. In this case, smoking. So this particular sentence says that the patient is smoking irregularly. So in an old-fashioned way, the researcher would go over these kinds of texts and then write down this information into a classification in his or her Excel. Of course, if you have a lot of data, that is going to be a really slow process for like thousands and thousands of patients. So that's why we trained a language model to do this stuff automatically. In this particular case we took just say that, okay, patient is smoking, so on. And the way we achieve this is by training an ULMFIT language model on the Finnish Wikipedia. What this means is that we downloaded the Finnish Wikipedia text and showed the language model what the Finnish language looks like. And after that, we fine-tuned this model on these particular smoking-related sentences that we had manually annotated to show what the language looks like in this particular context. And then we trained a classifier on top of that to classify these sentences into yes, no, or quit smoking classes. Nowadays, you don't have to train your own language model yourself if you don't want to, because they are freely available online. For example, for Finnish, there exist many different models, and this general Wikipedia model is also available online. And here are just examples what it would look like in code. So we just load the model into memory and then run predictions on different pieces of text. And if you know Finnish, it's quite clear that this works quite nicely. For example, here it says that risk factor smoking sometime in the past or in his youth, and the model has correctly predicted that, okay, this means that the patient has quit smoking. And that's it. This work was done at Albert Biobank with the University of Turku and Turku University Hospital. So in the future prospects for this particular model are quite interesting, because this pipeline can be used for other problems as well, as long as we just collect the training data for, let's say, alcohol abuse or maybe some symptoms or other interesting pieces of data. We can use the same pipeline to train models for that, to collect that data for future research.